So today I'm doing a bit more work on the silent air compressor. I'm putting a starting relay on it so that I could switch on and off more quickly. The reason I'm doing that is because with this, if you switch compressor off and then switch it back on again within about 30 seconds, it won't start up. And once that has happened and the thing, I came back, it was making a humming noise and it was roasting hot. That's because these PTC starters are pretty slow. You need to leave them to cool down before they'll actually allow you to restart the motor. This here as a starting relay, I did have it on the compressor, but it wouldn't work because the current relay, well, the coil on top was made of too thick wire. This is obviously for a bigger compressor, so I'm going to rewind the coil on top with thinner wire, about the same amount, so we fill up the spool on top, and then what that will do is hopefully generate more magnetism, because obviously it's more turns of thinner wire, and that should be able to activate the relay. So that is the new coil wound, and I'm going to test it, and if it works then I'll just solder the wires where they're currently crimped on just now, and that should form a much better connection. As working just now, I did a continuity check on the coil, and there's a connection there, but obviously you want to put solder on that. And this end here simply plugs into the back of the compressor, and then it gets wired into here, and then that goes up into the pressure switch, which has another cable coming out of it, which just plugs in over there. It's also got a starting capacitor. Normally when they're just using PTC devices you don't have one. You might have a run capacitor there, but usually they don't have it. But this is quite big, 80 microfarads. Right, so it's connected up. Let's see if it works. Switch off that. Right, so another thing we'll have to check is if we haven't put too much wire on it, because if you've put too much wire on the coil, then the more wire you add, that means it's going to lower the current required into the run winding, which will activate the relay. And if that's too low, then it'll be on all the time, and it could overheat. So basically I'm just going to check my watt meter. $255 watts. That seems about right. If the start winding was running at the same time, it'd probably draw quite a lot more. Another way I'll check it is I'll put my multimeter across the 2 points at the top where the relay makes contact when it's on, and if there's 0 volts across that, then that means that's bad, because that means the relay is still on. Right, so another check I'll have to do is I'll need to make sure that the relay doesn't engage when the compressor is under some load. So I've got our air tanks here. Now these are full, these are always full. So I'll switch these on. Yeah, that's 210 watts, that's fine. So that means that the relay is still staying off. Let's do another measurement. So that's it all tested and working. That's great, so the relay isn't activating when it's under load either, so I seem to have guessed the right amount of wire to put on it. I never did any calculations or anything like that. Right, and it should be able to start under load as well. With a PTC starter, it would struggle to, unless you'd obviously let it cool down until it was like at room temperature. Now that's starting under load, no problem, and that's almost at full pressure, which is about 9 bar. So that's a welcome modification. That's for this refrigerated air dryer, which I built myself. That doesn't need starting equipment like this because I switch it on and leave it running for a while. I don't need to be switching it on and off. The same with this sort of heat pump experiment here. There's meant to be a dehumidifier, but it actually keeps freezing up. Now, I think the reason that they use these PTC starter devices is because most refrigerators here in the UK, as far as I know, are using flammable refrigerants now, R600A, which is butane and various others. Now, these cannot produce a spark at all, but that one, the relay starters, they were probably meant for non-flammable refrigerants. I think R134A is not flammable, and they cannot be used in R600A systems because they produce a spark, and say there was a leak somewhere, that would cause an explosion.